Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Tabzan bin Ramli. My matrix number 07DEM23F1026.
Hello, my name is Shakila binti Ahmadi with number matrix 07DEM23F1020. So today we'll present about a relay topic. The first one is relay specification referring to NEMA. There are 4 relay specifications, that is NEMA contact rating. It specifies the maximum current and voltage the relay's contacts can handle safely. For example, a relay might be rated for 10 ampere at 250 volt AC. The next one is NEMA coil voltage. The voltage required to activate the relay coil, often 12 volt, 24 volt, or 120 volt, depending on the application. Next is NEMA environmental ratings. It includes the resistance to conditions like humidity, temperature, and dust. For example, NEMA type 1 is the general indoor use, while type 4 is waterproof and suitable for outdoor use. And the last one is mounting type. It describes installation methods such as panel mount or DIN rail mount, which affects the relay's compatibility with different setups.
I want to present about ladder diagram using relay. Ladder diagram explanation. Basic structure. The ladder diagram resembles a ladder with 2 vertical rails representing power and multiply rungs showing relay circuit. Yang kedua, relay coil. Next, relay coil. A relay coil is shown in the circuit and energized to control contact in other part of the circuit. Okay. Next, NO, normally open, and NC, normally close contact. Show how to the relay control different part of the circuit. When the relay coil is energized, no contact close to a low current flow, while NC contact open. Function used to automate procedure. For example, pressing a start button energize a relay coil, closing the circuit for a motor to run. Okay. Next, about positive and shift sensor. Positive sensor function. Measure an object absolute positive relative to a reference point. Example, a potentiometer can measure the linear position of a shaft, providing an analog voltage proportional to its positive. For example, this. Okay, shift sensor function detect movement of charge in positive over time. Example, a linear variable differential transformer LVDT measure displacement or shift, often used in precision manufacturing. Next, for example, sensor, velocity and acceleration sensor. 1. Velocity sensor function measure the speed of an object. Example, a tachometer sensor the rotation speed of a motor shaft, providing feedback for speed control in industrial application. 2. Acceleration sensor function measure the rate of change of velocity. Example, an accelerometer in a smartphone detects screen orientation by sensing gravity pull, essential for navigation and mounting tracking. Next, pressure and level sensor. Pressure sensor function measure the force extended by a fluid or gas on a surface. Example, a piezoelectric pressure sensor convert pressure into an electrical signal commonly used in hydraulic system. Level 2, level sensor. Function to detect the highest of a liquid or solid without a container. Example, a capability level sensor detect the level of liquid in a tank by measuring change in capacitance as the liquid level changes. For my slide, temperature sensor. Function measure temperature by detecting change in resistance, voltage, or other parameter. Example, a thermocouple measure temperature by producing a voltage when two metal are joined and exposed to heat, widely used in industrial ovens and furnaces. Two types. Other types include RTDS, resistant temperature detectors, for high accuracy, and thermistor for small range measurement.
For the next one is the visual sensors CCD and CID. As you can see in the picture, for CCD is charge coupled device. The function of this sensor is converts lights into electrical signals to capture image. It is used or found in cameras and scanners. In industrial application, used in quality control to inspect products for defects. For CID is charge injection device. The function is similar to CCD but allows individual pixel control and reducing noise. For the use, it used in low light application and where high image quality is needed, such as scientific imaging. For the next one is photoelectric sensors. The function for these photoelectric sensors uses a light beam, usually infrared, to detect objects. For example, a true beam photoelectric sensor consists of a transmitter and receiver. When an object interrupts the beam, it sends a signal common in conveyor belt systems for object detection. For this application, it can counting items, detecting position, or ensuring safety by detecting the presence of an object. For the next slide is microwave sensors. For microwave sensors, the function of it is emits microwaves to detect movement or distance of an object by analyzing the reflection of these waves. For example, Doppler radar uses microwave sensors to detect motion and speed, often used in speed enforcement by law enforcement. It is used in industry, detect motion in security systems, and measure distance in automotive and aerospace industry. For the last one is laser sensor. The function of this laser sensor is uses a laser beam to measure distance or detect objects with high precision. For example, a laser rangefinder measures the distance from the sensor to an object by timing the laser pulse. It often used in automation for precise object positioning. For the application, it can use for robotic, precision manufacturing, and quality inspection where accurate distance measurement is critical.